Hey, John here. Let's look at some surface mount soldering while I assemble this project board here. This is project 2057. It's an ICE40 HX4K breakout board. This is revision 3, and it has a USB-C connector for its power, and it has an SD card and analog voltage regulators and stuff like that, okay? So this is mostly going to be focused on the actual soldering of the surface mount capacitors and the TQFP surface mount package that the FPGA comes in. As always, I'd like to shout out a big thanks to all my Patreons, especially the VIPs. Thank you very much. You make all this possible. Well, let's start with something new that I've never even done before myself, and that is a USB-C connector that I'm going to use to power this board. So here's what I'm using here, these USB 4105 GFA120s from DigiKey. So this is what they look like. You can sort of see the pins coming out of the back there. And hopefully I'll be able to solder that boy on the board here. So that's where it goes. This thing I'll line down there, see if I got the right footprint. That's always fun when that doesn't line up. Those pins land very nicely on there. So why don't we have a look, see if we can get... The next thing is, one of these finely pitched parts, can we actually do the soldering? A little bit of some flux in there. And we'll get a little bit on the sides as well, because these need to get soldered in the through holes as well. Now, actually, we'd be best off, I believe, first getting the socket seated on the board before we start doing the fine pitch parts. So I'm going to hold it, flip it upside down here, and see if we can do a little bit of this on the back first. Now, these pins don't go all the way through the board, which is a little bit of trouble, but I think we're going to be okay. Now, they make different styles of this product that have different lengths of these pins. They call I think they refer to them as the spikes. When you buy it, they have different lengths. So maybe you can get them a little bit longer than I did, but I had they were out of stock or something like that. I usually buy the longest ones. Oh, it's not spikes. I believe they call them stakes. It says stake length on there, and I think that's what they're talking about. The through hole pin length. So these are very much not through the holes. This is more like an in-hole pin. All right, so that's definitely soldered on there. Now it's a matter of getting the surface mount pins in right. Okay, so what I'm going to do is going to put a little bit of solder on the tip here. We don't have to worry about the flux that's in this solder I'm using. I'm using the flux that's on the board that I put on with the syringe. Now, I don't know if that's actually, I don't think I got real solder on there. I certainly heated up the flux. Now there's definitely solder on there. I don't know. Let's see what we're doing here. Now, either accomplished nothing or it's soldered in. I think that's flux on the back. Hopefully I didn't melt it. Now I'm going to grab one of these thingies here and do a close-up on there and see what it looks like. Oh, that looks beautiful. Most of the pins look like they're in there. But the pins on the right side over here don't look like, there's one like right in here, and then this last one doesn't have any solder on it. I did a little bit of solder by braille there because I absolutely cannot see with this setup like this. The camera's in the way and there's glare everywhere. For this particular solder job, kind of hard to see what's happening there. Let's see there. Oh, yeah, that second in pin over there, right above the O right here. It looks like there still needs a little. Don't know if I got enough solder on that one. I don't even know if that pin is in use in my circuit. That's the other thing, you know, you don't actually have to solder every pin down. If you're not using it, you can kind of let it go if it becomes a problem. Wow, that went on absolutely beautifully. That's good. So it'll probably look a whole lot better once we clean it up. A little bit of alcohol. Some Kimi wipes drenched in, what am I using today? 91% isopropyl alcohol to wipe up my to clean up my no clean flux is what I'm doing. So, I mean, I guess you can leave it on. I think when they say no clean, what they're really meaning is that it won't cause the board to degrade if you were to leave it on there. Because some flux will, I mean, you know, it can cause a chemical problem over the course of time if you never clean it off. So I think that's what they're talking about. Maybe some of the other graybeards can opine on that. How much am I telling the truth? Anyway, that's what somebody told me when I was a kid, you know, my electronics teacher or something along those lines. How about, it looks like I may have done a number on that. Did I melt it a little bit there? Maybe. But that's actually okay as long as it doesn't interfere with what's going on inside there. And I'm suspecting it does not have too much sensitive stuff in the back. I'm certainly hoping not. So here's fingers crossed that it doesn't have too much sensitive stuff inside there. Jack goes in, it feels really good. Oh yeah, that's in there. That's in there. So even without the voltage and the current, whatever biasing pins or whatever these things, whatever technical name they have for those are the ones that are used for the you know, the USB-C intelligent power supply to be able to figure out how much current that the board should be allowed to have so it can throttle back. If I don't put them on there at all, I have absolutely no idea what the power supply is going to do. But I suspect what it's going to do is think it's not a USB-C and simply provide up to a half amp like it would normally do if I plugged in any other cable into my charger. And that is exactly what I want, so I can put a probe on here and find out, is this thing sending 5 volts over here or not? Okay, plugging in the power supply. This is ground, well labeled, right? And one of these should be 5 volts. Oh, baby. Yeah. So you might recall the design here. What happens is there's a jumper here that when you put this jumper in, it allows the 5 volts from, if you plug this into a Raspberry Pi, to then power this whole board from the Raspberry Pi. Or, I guess the same is true the other way around. If I put the connector in here and I put this jumper in, it'll allow 5 volts to flow from the board into and power the Raspberry Pi. And yes, I'm quite aware of the fact that the Raspberry Pi Foundation recommends that if you do power the Pi through this connector, that you put diodes and stuff in here to protect it from reverse polarity, etc., etc., etc. I just checked. We're good. Okay. Alrighty. This is just great. That was real easy to put in. I'm very happy about that. These are my new go-to power connectors now. So it would be nice to put in our 17 and 18 now, and then maybe put a load on this and crank it up to see if it does in fact provide the right amount of current. In fact, maybe we should do that before we put the resistors in. Yeah, let's learn something. Why not? Let's start loading this thing down and see what happens if and when the power supply shuts down. So who recognizes this, right? It's a wire wound rheostat, okay? And what kind? This is from, yeah, it is. You can see the logo in there, I think, MRC. This is an HO gauge train throttle rheostat from Model Rectifier Corporation. It is one of my favorite dummy loads to use for, you know, not too high amp loads. You know, an amp or two is fine. And it's all ceramic. This sucker will heat up. When you bring the wiper around like this and you start drawing a lot of current, this thing starts hitting a little bit toasty over there. All right, so here we go. I need a good ground. I don't really have, let's see, we're going to have to put this over here so we can plug this in. Okay, the power on this is off. So I can do this. I can go with ground there, and I can go with 5 volts here. And what I really need to do is put a meter in there so I know what I'm doing. Okay, so here's the rheostat, little meter. We'll put it on amps over here. It'll, of course, scream if we don't have it right. Milliamps, microamps. Well, we can put it on amps because we're going to crank it up to 1. Of course, I don't know how 400 milliamp. Yeah, this says 400 milliamps fused. So we want to be over here, okay? Because I'm going to draw more than 400 milliamps. And I don't want to flue abuse in there. Okay, so what I'll do is I will touch this to here when I want to draw current. I'm going to clip it in line with the rheostat over there. Okay, I actually get this out of the way. Get this over here. We can go to ground here and power there. Okay, that's good. So I'm going to power up my USB power supply. Make sure the wiper is in the off position, so it's wound all the way away from this pole over there. So this is completely off. No current will be drawn. And we can check that by touching the power and the ground here, and the meter says no current. Now I need an extra hand. Let's see if I can clip this on here. This is ground, I'm sure. Yes, in the schematic I grounded the case of that. Okay, so now we're all set to go here. Okay, let's crank up the current and see what happens. What do we got there? Where's the decimal place on this thing? I'm in milli. So I'm in the amp. The jack is in the amp thing. I'm in the milliamp scale. So that's not a lot of current. So we got 100 milliamps, 200, 300, 400. Now, it should not give us more than 500. Of course, it really depends on your power supply. So I've got an amp coming out of this thing, and you can see the rheostat is all the way over there. I am very suspect here. I'm not going to want to draw it. I bet the cable is going to start getting toasty in a minute. My USB cable over here. Wow. Is this connector warming up or anything? How about Mr. Rheostat? This can usually get 9. It'll let you know. All right, let's go ahead. And, you know, this is probably, well, why not? I don't want to burn any traces off the circuit board. In this particular project, I'm not even going to draw 500 milliamps, that is. I suspect that the power supply will cut down after a while. Look at that, 1.5 amps. I'm not going to tempt fate here. I don't want to wreck the connector or the cable or the power supply or anything. Wow, nothing's heating up. Wow, that was unexpected. I should try that again with a crappy, cheapo one, because here is the power supply that I'm using. This is an Anchor one of these things with a whole bunch of ports on it. I don't know. It's like total output current rating. I don't know what the heck the... I'm going to need a magnifying glass to read the thing. 5 volts, 12 amps total, 2.4 max per port. So I suspect we'd have to crank that sucker up to 3 before it does anything. And yeah, well, why not? Let's find out. If I burn it up, I'll just get another one. If it torches, I will just, you know, that's why JLC PCB gives you 5 boards when you order. All right. What I don't want, oddly enough, I don't want to wreck my cable. I don't have a lot of cables. The USB cables, that is. All right, so let's crank it up this time. We'll bring her up to 2.5. Ooh, 7 and 1.5. Wow, that's 2 amps just for a little while. Ooh, 3. Nah, they lie. They don't have automatic shutdown on that thing. This can, if you do that, don't do this at home. Don't do as I do. Do as I say. This, or at least, wet your hand something before you touch this thing, because this can get really hot. Okay, so the good news is I can get a lot of current out of this connector, and nothing's heating up. I'd say that's a successful test. All right, so I'm very excited with this connector here. Now, of course, on the preview monitor, I can see I put this stupid J4 right in the middle of the power only right there. It should be over here. So I'll probably move that silk screen over to the side, but I'm certainly not going to order new boards because of that. But at least, yeah, if anybody else wants to make one of these, it'll work out. So the next up is this SD card connector. Now, I've had trouble with these in the past. These have been the bane of my existence, and I've yet to try this. But what I've done here is I redesigned the footprint by increasing the size of the pads in the 4 corners that go along with the metal housing on this connector. I mean, I can solder the thing in, but I can't get the housing attached, which means that, it'll work, but you got to be careful if you don't get the housing soldered down right on your board, because it might be too easy to crack it off of the board when you're inserting and removing SD cards. So what I'm going to do now is see if these make a difference. I'm pretty confident that it will. It's only 0.5 millimeter of extra copper that sticks out around this housing. And I believe that'll be just enough to get the iron on these corner pads, so there'll be enough heat in there for the solder to get on there. I'm really sure that's been the problem all along. So we'll be about to find out. Alrighty. So let's go ahead and put a little bit of flux on these pads. Ooh, a little much on that one. And the problem is, I've said before, you can always put too much flux on and then clean it off, but if you put too little, you'll never get the darn thing to go on there. But in this case, you have to be about right, because what happens is, if you put too much flux on this and it all gets underneath this connector and on these pins and stuff in here, you'll never really get it out, because how are you going to wash out from the inside? I mean, I suppose you could soak it overnight in a little, tray of alcohol or something. But, no. So the point is, you need to make sure you don't get it in underneath the, oh yeah, that's it. Now ooze out a ton on there. Way to go, John. All righty. Well, at least we can wipe it off before the connector's on there. All right, you can actually wipe the whole thing clean like that. and start over if you really want to, or in my case, if you really have to. You can also go a little light on the flux on these pins because you can always add a little bit more later if you need to. But these corner jobbies, oh, there we go, need to be correctly fluxicated right now. All right, let's see. Maybe I can hold it like this. Yeah, that's not too bad. Set it on there. Okay. That doesn't look too bad. Now I'm going to use this so I can see what I'm doing here. Get it centered on there. Check all the pins, all the corners, all the king's horses, and all the king's men. All right, it needs to go up a little more. There we go. All righty, so what I'm going to do is I'm going to tack in one of these little pins in here because it'll be real easy to do, and it'll be real easy to undo if necessary. As always, we'll put a little bit of dab of solder on the iron tip here. It's probably too much. Hold down the connector with something so it doesn't move. Try not to move it while preventing it from being moved. Okay. I got one pin soldered on. And it's already kind of twisted, rotated, but I think I can work with that. I want to make sure that I got the pin in the center of the pad. And I do believe it's good. Right now I'm going to go in this other corner. And I am going to solder this one in, and that'll hold it aligned on the board while I try to solder the case down. Okay. We'll do the case corner. So that went right on. Let's see about this one here. Well, that one went right on. I think we have a solution to my problem. Oh yeah, we hit it with this thing and we look up really close. That is definitely soldering it right in there. Let's try this side. This corner here has been the bane of my existence right here. That one right there. On all other cases. I don't know if that's on or not. We'll have to get a close-up view. looks pretty good. Look at it with a magnifying glass. A lot of glare here. Sorry about that. That looks pretty good. The first time ever. Look up really close here. Well, all the corners except for the annoying one are on fine. So this one didn't go in, but I think I just need to heat it up a little bit more, and I'm pretty sure it will. There we go. So that I am pretty happy with. Okay, so let me just do the other pins on the SD card here. Data pins, etc. Power pins. I think we're in business. And with that, I do believe I have solved my SD card soldering dilemma. Now, before we get too many expensive parts down there, I like to put the regulators down. So we got the USB. We know that that had 5. I put the meter on here and measured this at 1.2 and 3.3. So the power train is good. The regulators are in the right spot. I didn't reverse, the 3 and the 1 and put them in the wrong spot. And I like to do that before and measure it and everything else before I put down anything expensive or time consuming like the FPGA. So here we go. I got a brand new pack of 3. Let's take one out and have a look-see. These ones have much brighter and easier to read writing than most of them that I have seen. Well, let's go as far as to question the authenticity of these. But I got them at DigiKey, and that's a pretty reputable place. I'm sure they know the origin of these things and could vouch somewhat for their authenticity. So I'm sure they're okay. That slug right there indicates where pin 1 is supposed to go, and you can see a marking. Is that the right marking? No. There's a dot. Maybe it's right there. You have to look pretty close on these. It's kind of hard to see with all the foil and crap in the way here. Where's pin 1? I believe pin 1 is this dot right there. These are like sprue holes or something from the injection molding process. It's definitely going to be this dot here that's the number 1. Plus, it's got an angled corner. I guess they all have angled corners. Well, you'd think they'd make it a little more obvious, but that is pin 1, okay? So it goes in like this. The first thing we need to do is make sure we got some flux on there. Come on, I get a little bit of a glare. I can't really see what's happening over here. Come on. Great, I think I managed to clog the needle somehow. So I will throw this in my, what I do with my needles when I'm not using them, I just throw them in a jar of alcohol like this for them to sit. And that causes the the flux inside of them to soften and dissolve. So that will probably be okay in a day or two. Meanwhile, that's why you buy many of these. We'll try another one. That's a bag of a bunch of different sizes and types. I'll try one of these. It has a little bit bigger hole. Maybe this won't clog as easily. I don't know. Whoa, it's definitely flows a little quicker. We'll blot some of this up so we don't have 3 gallons of it in the way. That seems okay. Now, the way you want to do this is you want to get it basically placed in there, and then you can kind of nudge it around to get it centered on the right spot. Now, you don't want to just slide it over here and smear the flux everywhere, so I need to kind of do, I do it something like that and kind of set it down, and then kind of tap it around until it's in the right spot. Oop. So now I'm smearing the flux. That's not always a good thing. Yeah, get it nice, evenly distributed, smeared all over the entire place. Most of it ends up underneath the chip anyway. If you've ever done any rework on something like this, there'll be like a ton of sticky goo underneath here after we solder it on. All right, now you want to make sure that you don't have it, up on an angle. So it's like a Pringles potato chip or something like that. And then you're going to have to get out your loop like this and give it a really good eyeball, really up close. And what I do is you go into kitty corners. You got to make sure these pins are on the pads and the ones over there, okay? Once that's true, then they all have to be. You can see this corner looks pretty good. We got to come over to here. And this corner looks okay, but it's not quite perfect. It looks like it's too far here. So I'm going to go to the other end here, and I'm going to give it an ever so slight nudge. There you go. Now I think I screwed this up. So this process is kind of annoying. It takes a little bit of tinkering around. And when there's too much flux, you can't see what's going on. So I'm going to kind of wipe some of it away. And in doing so, I might end up bumping it and nudging it around even some more. Here's some pins that don't have as much flux on them. And you can see it looks like the pins are in need of a slight nudge in this direction. There you go. That's looking pretty good. This looks good. These are looking really good right in there. These look good. That looks like it is adequately centered. Okay, now what you do, you're going to have to hold it, because when you touch this thing with an iron, it'll move again, right? So you get a clean tip and you put some solder on it like I've been doing all along, a little bit of on there, not a ton. And you're going to have to kind of like stick something, right? You're going to just poke it and smush it down on the board without sliding it around. And that might require a little practice. You don't want to come at it really slowly while your hand is jittering, okay? You just want to plant it, sucker on there, and smack it down. That corner should be soldered in. Now, before I do anything else, I'm going to get my loop. And I'm going to look very closely again in the 4 corners. All right, the corners are all lined up really nice. And I can also see, when I looked up super close. There's definitely a solder bridge in there. Who cares right now? Don't worry about that. That exists for a little more reason than to tack it down. This corner cannot move. However, this one can still slide around like this. So you need to get this corner tacked down. Once that happens, the chip will not move. Won't move much. So I'm not going to hold it down with the tweezers this time, but I do need to be very careful that I don't move it with the iron, because it could move. All right. Well, that's all I'm going to do is just basically, once you touch a pin, it's soldered down. Okay. Not a lot of thermal mass in there. There's just nothing. So it heats it up right away, and it should hit it with solder right away. And there's a ton of flux, so it should be fine. So that looks good. And now it's about the other corners, and then you can just do the whole chip once you get that done. A little bit of solder on the iron. Come in here and just touch it. The solder should flow pretty easily. I think that one's already done, but let's go ahead and overdo it. Okay, just to make sure that's tacked down. Again, we'll clean up the bridges later. When you get really good at this, you can do this much more quickly than I am here. And trying to narrate and everything else. Again, it's really not going to move at this point, but I want to make sure. We got all the four corners tacked down. Now, the reason you want to get the four corners tacked down before you start doing everything else is because if one of the corners is lifting up off the board, you could solder it all in, and it'll then be like in that orientation, which could be a real problem. So it's flat on the board. All the pins are lined up. Now, I can see that there's not much flux right in here. That could be a problem. There's a ton extra there, so I'm going to just kind of move it over. Now, if you're going to do this, don't ram it down on the pins. These pins bend very easily. Once you bend it, you're kind of going to have a lot of trouble. So if you're going to do this with the tweezers, what I'm doing is dabbing up and down like this at it, okay? I'm not really going that much side to side. I'm kind of going up and down while I'm moving around in order to distribute that around. It'll kind of go on its own anyway once you put the hot iron on there, because it'll flow all over the place. You can smush it around with the tip of the iron. So I'm going to load up a little bit of solder, and now I'm going to just glide along this edge, right? This is called drag soldering. You can just drag the tip along these pins, and I can feel the pins as I go. Right, I'm on the pads, and I'm dragging it along the pins, and I'm not putting any pressure on it. In fact, I might even be putting a little bit of pressure, lifting up the iron so that it doesn't touch very hard against the chip. And that's all I did. I just dragged it along the edge. There's a big goober on the end. There's probably going to be a bit of a bridge there. Now I'm going to look closely to make sure there's enough solder in there, because sometimes you'll go through the whole thing and it'll leave solder like on the pads, but it won't actually solder the chip on. If you do it if there's not enough solder on the iron, that can happen. Now, other than some solder bridges, that looks pretty darn good. And the solder bridges are in this area right here and on the end. I get a lot of solder bridges on the ends because what happens is there's a big blob of solder on the iron, and then there's nowhere for it to go when you run off the end. So you can kind of get rid of it if there's too much on there by kind of combing at it like that, and I think that just did it for me. And this is a lot of technique that you kind of figure out as you go. You learn. If you screw this thing up, you can use solder wick to get it off, whatever your favorite technique is. Now that edge is on surprisingly good. Normally it doesn't go quite that smoothly for me. Now you can definitely see there's a big solder bridge right there. but I think it's like paper thin. So what I'm going to do is this combing motion that I like to do, like this, and kind of comb it outward. And what I'm doing is I'm wiping off the tip of the iron a lot. So what I'm hoping I'm doing here is drawing the solder onto the iron, and then I'm going to get rid of it by wiping off the iron in some copper wool. You know, this stuff here, like this. Okay. I think I got it done there. Let's take another closer look. Okay, so that's that side done. No bridges. Looks really good. Now, you don't really know it's done until you've cleaned off all the flux, by the way. Because right now that looks like there's perfect fillets along that whole edge. And sometimes I'll do that, and some of the fillets are really just a little bit of flux in there that makes it look a little bit shiny and fakes me into thinking it looks good. So that'll all kind of pan out in the end. Once we clean it up, we'll get another look at there, okay? So here's the next one. I'll do the same technique. Kind of, well, that looks like I'm going to bend a pin. I felt it hooking on the pin there. Sometimes this is easier. It depends. You know, how it feels. And the iron rubs along all those pins. Okay. I don't think there's enough solder on here to finish the whole thing. I think it'll get dry by the other end. So I'm going to go ahead and throw, oh yeah, that's a nice big blob. That's a lot of solder. I'll clean off the tip and start trying to smear it along as we go here. All right, that's what you do. Big old solder blob, just kind of spread it out. And again, I have a big blob. That's a huge solder blob on the end, but you can kind of comb it. That one won't comb out because I can tell there's just way too much. So I'm cleaning off the iron. I'll just kind of keep doing this a little bit until I get it all out of there. And usually when you're done, you get a little bit left. Sometimes I can't get the very last of it like this, okay? And what you can do is kind of evenly distribute it along all the pins like this. And kind of hide it, distribute it around like that, okay? You can only do this if you don't put too much on to begin with. I've seen people put like a mountain of solder on these things, giant wad, and then go in there with the, the solder wick and clean it up. But honestly, I think that's a waste of solder, B, a waste of solder wick, and C, a waste of time. Once you get this technique down, you should be fine. I'm 10 tons of overdoing it here for sake of explaining and to demonstrate like this combing kind of action that I find useful when I'm trying to get rid of or evenly distribute a lot of excessive solder around here, okay? Now there's a lot of glare here. Some of that's flux. And don't confuse yourself into thinking that just because there's glare, there's actually solder in there. I'm pretty sure that's a good joint right now. All right, that side looks pretty good. Next. Again, you just put a little bit of solder on the tip. It's probably enough to do the entire side. Sometimes I start on an end. Sometimes I start in the middle. You know, I like to get jiggy with it. And again, if you feel it digging in and getting hung up on a pin, do not drag it. Take the pressure off. You want to basically kiss it like an angel here. Otherwise, what you'll do is you'll hook a pin and bend it to the side. Then you'll be in the, oh, okay, I need to bend it back now game. And these pins are so insanely brittle that once you bend it once, you'll break it off getting it bent back. You're gonna mess it up. So never bend these. Absolutely highest priority, don't bend the pins. A little bridge in there. Yeah, come on. Actually, that could be flux glare? I don't think so, though. I'm going to have to go in there with a loop. There's too much shininess in the lights and everything in here. Oh, that's definitely a solder bridge there. Okay, so let's see here. Let's see what we can do about it. Well, I think it's good. Once it's not bridged anymore, stop messing with it. It doesn't need to look gorgeous. It just needs to be right. And I stop messing with it as soon as it looks like it's got fillets everywhere and not bridged. If you really want to make it look pretty, you can go back with hot air and reflow the whole thing. And what will happen then is that all the solder will evenly distribute itself, and any, cusps or pointy edges that are caused by, the fact that you had an iron that was dragging along or anything like that, all become perfectly evenly smoothed out, and it looks like it's perfectly like factory done. When I make boards and I give them to other people, I do that a lot, and then they're like amazed. When it's just for me, good enough is good enough. Besides, if you reflow it, what you're doing is you're heating it up an extra time. It goes through all this thermal heating and cooling and heating and cooling, and that is not good for it. Even though it looks nice, it may not be nice. I'm not sure I had enough solder on the tip. I don't know if some of these might be a little dry. No, the loop says all's well on there. I like to clean off the flux as I go, mainly because, like I said, once the flux comes off of this, it could reveal some bad soldering in there, which I'd like to take care of before I got all the other parts on here and in the way of what I need to do here, if I got to clean it up. For this, I just use an old toothbrush with some more isopropyl on it. I do not recommend using the toothbrush in your mouth after this. Boy, I gotta say, that's probably one of the quickest, cleanest solder jobs I've ever done, especially while narrating. That, I'm very happy with that. If you've never done this before, do not expect it to go that well on your first try, okay? Expect it to take a little more work, especially if you get some bridges and stuff in here. And if you put too much solder on, you're definitely going to want to have some solder wick around to get the excess off of there, okay? But, like I said, if it's your first time, don't get too frustrated, because that's what's going to happen. It took me a couple of times before I got my first one to be soldered in there. In fact, I had some old chips that I used, some old UARTs, in fact, that I used to practice on. And if you search around in DigiKey just for, any other parts that come in the same packages, maybe you can find a part that's only $1 or something so that you can use them and throw them away, is my point. You don't even need a chip of the same size to do this sort of thing. If you get one that's smaller but has the same lead pitch, you can put it in a corner and just do two sides, all right? Again, just find any cheap surface mount part and practice on if you do need practice. Okay, this thing cost me like $10. I don't recommend wasting $10 chips just for practice, unless you're just won a lottery or something. Alrighty. Oops, I forgot. We got to put the oscillator on. Little metal can oscillator goes right in there. Now these things don't even have any real pins coming out of them. They have these corner things, right? There's what some manufacturers call a land grid there, but they also wrap around the corner, okay? Now these things, the middle of these three on each side are not connected to anything. They're just floating anywhere. So what we really need to do is we need to get the four corners soldered down, okay? Now, pin 1 orientation on this is not all that easy to see. Although, you know, funny, I just look at the preview monitor, you can clearly see the dot right there. Pin 1 on these guys is that dot. And on the footprint here, it's the angled corner up there. So the pin 1 goes up there. So the right way for this chip to go is to come around like this, okay? So this part sits right on there, all right? Now, when we solder this on, remember, these pins kind of reach up and around the side. You can see the three there. Now, what I'm going to do is I'm going to put some flux on these four pads. I'm going to put the chip down. And then what I'm going to do is I'm going to run the soldering iron along the side of this and just stick it in this groove. You can see that there's little notches, the three notches on each side of this thing, right? So I'm going to just set the iron down in this notch and heat it up until I see the solder flow. And what it'll do is it'll flow onto the board and then it'll flow up the side of this of the case. So let's go ahead and put the flux on these pads. Oh, that's a ton. That's like enough for the whole thing. Now, if you smear it around like this, it'll be okay if you have to. That is a lot. But like I said before, not enough is a death warrant. Too much, you can always clean it up later with a bunch of isopropyl alcohol. Again, that little dot right there is the pin 1 orientation marker. Okay, so you just sit her on there. Now, like that SD connector footprint, this footprint I made bigger and I let the copper stick out a little further than the original footprint that came from DigiKey, by the way. And if you do use this same part and you use the DigiKey footprint, I sent DigiKey a note to let them know that they screwed it up and they numbered it wrong. So if you do this, look very closely at the pin 1 on the footprint and everything else because they did it wrong and I had a whole board that failed because their darn footprint was wrong and I didn't notice it until after I built the whole thing. Ain't that a pain in the butt, okay? So maybe they fixed it, maybe they didn't. It's right on this board though, because I've been messing around with this design for a few years. All right, now as I push down, you just saw tons of flux ooze out the side. All right. I'm going to go in this corner here. And what I'm really doing, I can't see anything, right? I'm feeling around with the iron to feel that notch on the side of the part. Now, I'm going to guess that's long enough to solder it in. It doesn't look quite right, but if I can nudge it around, then that means it didn't get soldered in. Okay, it did not get soldered down. All right, so we'll try again. A little solder on the tip. Maybe I'll put a little extra. It's not, you're not going to get a bridge on this thing because there's nothing to bridge it to. You can put all the solder you want on the iron. Now I'm pushing down on the circuit board fairly hard. I mean, I don't know, relatively speaking. Hoping that I got a good thermal contact with it. I'm going to do this corner over here. Oh, look at that. Nope, it's still not down. Dang it. Now, it's possible you can see the pins here. You can't see them on the other side. I think I might have the whole thing too far to the right here. As the flux starts melting. There you go. Now you can start to see the pins or the pads reaching out from underneath it. But don't push it too far, because then you can't do the other side when you're done. Come on, get in there. Now, there's another way to do this. You can pre-solder those pads, and you can use hot air, which is what I'm going to do right now. I've never actually done one of these with hot air. I always usually just wrestle with it with the iron until I get it right. But just for fun, let's put some solder on the 4 pads. This is a ton of solder on there, okay? If you put too much on there, it might actually be a problem. So let me clean off some of it. I'm going to do the same kind of thing with a wicking away. Put it on the iron and then wipe the iron off. Like so. Alrighty. I'm going to put it back down. Now it's up in the air because it's sitting up on top of those. Now it's on my finger. Now, once you're done clowning around with it, you got to make sure you got the right pin 1, the right spot. And now it's all covered with flux, so I can't see anything. This is, you know, typical crap you go through, especially if it's your first try. This kind of thing will happen a lot. Don't get too frustrated. Just deal with it and move on. And try again. All right, there we go. Now, most of the flux is probably missing or boiled away at this point. So, and I just wiped the part off. So there's not really any flux on that. So we're going to have to reflux it. A little bit on there. Okay. Not to get it on the circuit board, but to get it on this part here. Now, if we heat it up with air, it'll sit down on there. And then it should be fine. There's an awful lot of solder right now in there. I hope this is going to be okay. I never actually tried this before with these parts. With the hot air. Well, let's see what happens. I don't know if I can keep it so you can see it on the camera while I'm putting the air right on the thing. I don't want to heat up the, you know, everything else too bad. There it goes. I can start to see the solder starting to melt. What it'll do is it'll kind of walk around a little bit, and it'll actually center itself due to surface tension once all the solder melts. Sometimes it'll get, there it goes. See how it's moving around? Actually, that's the air blowing it around right now. It's gliding around on a surface of molten solder. So I'm going to take this off, and I'm going to let it air cool. I'm not going to blow on it. I'm not going to hit it with cold air, because you don't want to thermally shock it. You want it to just cool down on its own. And it won't take much time at all. By now, the solder is probably stiffened up enough. But because I used hot air, the entire board is probably thermally on fire. If you touch it or something with your finger for a while, it's going to be, you'll burn yourself. So don't do that. Don't pick it up and go underneath there like that or anything else. Let it cool down. And that beep is the sound of my system letting me know that the hot air gun cooled down. Now, while this was going, I probably also melted the solder around these tabs, which is fine. You know, it can reflow. This one actually looks like it has no solder, but what it did is it all ran up underneath there. I'm sure it's fine. If you're in doubt, you can go in there with your loop and take a close look. Now, this is what the joint should look like if you do it right on this oscillator here. You see how these little solder wicking up inside these things on all 4 pins. Middle ones are not soldered. That's as good as I've ever seen it. I think that the hot air is the way to go with this thing, all right? Again, this little dot is pin 1, and pin 1 goes in this rounded corner in here. If you can't see the rounded corner, you don't know, and you can't figure it out based on the circuit board, open up your schematic and look and see which pin has a 1 on it. Don't guess. You'll guess wrong, and when you power this thing up, it'll heat up to a zillion degrees and then burn itself up. You don't want to do that, right? So you can maybe get a better look at some of these pins or the fillets on them. That looks pretty darn good. Like I said, this is probably the easiest I've ever had soldering in one of these kind of packages. So I'm pretty happy with that. It's all just practicing technique. All right. Again, don't get too frustrated on your first try. Expect to throw the first one away. Okay. But once you get it, then, the world's your oyster. You're not confined to only working with through-hole parts anymore. And let's face it, it's hard to find a lot of chips these days in through-hole packages. Well, the next thing I'm going to do, okay, now I'm going to do the little EEPROM here, and then I'm going to go for the discrete parts. And because some dingus forgot to turn on the camera, I did the EEPROM without the camera on. Moving along. The thing about the EEPROM here, it's really easy because the pins are much farther apart, as you can see, than the FPGA. No big deal. I probably used the wrong footprint for this particular part because these feet land really far in at the inner edge of these pads that reach way out the sides like this, okay? I'm going to just go with the fact that, these chips are available in differing widths. So, yeah, if you get a wider one, it'll fit. That's my story, and I'm sticking to it. If you get the same thing I do, these pins just barely reach out and hit these pads, okay? But you can get them in there. The thing about these EEPROMs is you see the case. Oh, it has a rounded edge on this side and a sharp one on that side. Well, the rounded edge has pin 1 on it. That's how you're supposed to figure out which way to put this in. Put the rounded edge over here because, as you can see, I got the pin 1 marker right there. This is the way this thing goes on here. Now, C18 and C20 are the input filter caps on these regulators, and those are supposed to be 10 microfarads. And I've got some 10 microfarad 25-volt caps here. Now, these are kind of nominal. You can always use bigger ones. In other words, you could just put 22 microfarads for all 4 of these input and output filter caps. These are usually kind of a minimum size rating in the specs. If they're ceramic, you probably don't have to worry about making sure you have a big one and a little one and stuff like that. But if there are other kinds of capacitors, you do need to make sure there's a bypass cap in there sometimes. So you got to read the data sheet and what they recommend. So there's the caps. I'm going to use the inputs. Boy, this has been leaking a little bit while it's sitting there. Let's put some flux on there. Let's do all 4 of them at once. We'll do the other ones right away after. And I do these by value. I get a little bit of flux on here. Do all 4 of them. Why not? While we're making a mess, we'll do the other values right away after the 10s. Now, these are, even if they are marked, you're not going to see it. So the problem is you don't want to mix up the values and put the wrong ones, where you're at. So I do these in order kind of like by value. And that's why these are 10s sitting there right now. And I'm going to put the 10s down first. Now, the way I do these is I put down, I've shown this on my channel before. And what I do is I put a little solder dot down on one of the pins, the pads, I should say. Okay. And I take the part and I hold it with the tweezers, and then I solder down the one end. Now look what I've done here. I put the solder on the pad first, then I put the part down. The part is mostly covering this pad, okay, while the other pad is sticking out. You don't have to have it hugely off center, like I think, mine's not terribly off center. It's kind of an optic illusion due to the flux causing glare over there. But you need to make sure that pad sticks out the side. Worst case scenario, it can completely cover the other pad. All right, if you cannot heat up the pad, it will not stick, as we found with that lousy SD connector that I've had trouble with in the past. So I'm going to do the same thing here, heat it up, make real sure that the non-soldered pad is exposed. There's a real extreme example of me putting it off center, just to prove this point. It's okay for it to be like that, okay? Now I can heat up the other end, and I don't have a problem. If you leave this end covered, you will not get that sucker on there. It'll be a really big pain in the butt. Better look at that. I can't even do it when I got it exposed. Come on. Oh, you know why this is? It's because you see all the copper, this big trace that flows in and underneath here? There's not a lot of thermal relief there. It takes the iron a lot longer to heat up this pad here because all the copper that's going away from it. Same thing's going to happen on 21. A lot of copper here, but this has got these little spokes around it to make sure that they call it thermal relief, so that there's no the heat stays on the pad when you're heating it up. Okay, in this case, it all runs down the copper track. And that's okay. It's a little annoying, but it just means you got to heat it up a little bit longer. It should be enough. Okay. As always, grab my little loop and take a close look. And it looks good enough for me. So the other ones are 22. And here those are. Now these are a slightly different color, which helps, especially if you foolishly try to pull out all of them at once. But that's rarely the case. And that's why I did not want to get them all out at the same time. A little dab on there. And as I'm doing this, I realize I'm giving you a really bad example. I should have done these that I'm doing now before these other ones, because now I have to poke my iron in here and I have to be more careful. All right. Now I don't really care. I'm used to this, but if it's your first time, you may want to do these in the opposite order that I'm doing them. And on this one, you'll notice I also heated up this end first that has the track on there that has all the heating problems on the input caps. And the reason is because it's easier to put solder on there now on a track like that than it will be to do it later after the part's half covering it. Again, I should have done the other one in that order as well. And it's one of those things I forget every single time I do it. And I got to relearn it. So if you watch this thing as a preview before you put yours together, maybe maybe you won't make the same mistakes I do. Learn from my screw-ups. Now you'll notice this capacitor is kind of covering that up, okay? Now I could probably get that on there, but you know what? It's pointless to tempt fate. All right? This one over here looks good. This one's kind of not showing a lot there. Only got one of them ends soldered down right now, so it's real easy to just do this and move it over a little bit or a lot. Oh, now I'm going to screw it up. There you go. Way to go, nitwit. Okay, there you go. Don't be a nitwit. Do it right the first time. Okay, there you go. Little solder on there and get the other one down. These will go down much easier than the ones with the track if you get the heat on the board and not just on the capacitor. Wow. Or so I believed until now. Whoa. So that's another thing that some of these will do. I'm going to leave that one crooked because I'll show you another thing in a minute. These can actually pass a lot of heat through them. And what I did there is while I was soldering one end, I kept it on there a really long time and I ended up unsoldering the other end is what happened there. Okay. And yes, that can happen. So be careful. All right. So that one's on there. They're both on there. Now, if you get one that's crooked like this, you just leave it and nothing bad's going to happen, really. It's going to be fine. But let's say you don't want to look at that disgusting mistake for the rest of your life. Well, you can reflow this thing just like that crystal. And when you do this sort of thing, be careful. There's plastic in this USB connector. So if I hold it like this, I can melt it. Don't do it that way. Do it this way. All right? Now, when these things melt, they'll realign themselves on their own and straighten out, again, due to surface tension. It's really tough to do this once you put these headers on, if you put these on, because they have plastic in the base and they'll all melt. I know, because I've done that before. I've tried to, and they definitely will melt, okay? I think they're actually melting now. That one looks like it's probably melted. If you don't really know, you can sometimes tap the board a little bit and it'll move a little bit. But I would have expected to see it twist itself a little more by now. There you go. You see how that just moved? There you go. They're looking good. And if you want to, you can kind of redo these. And it really makes the solder kind of ball up and look like it's super duper professionally done. Because when you do it professionally, this literally is what they do. They don't blow hot air on it with a little wand like this. They just do the whole thing all at once in a giant oven with a bunch of infrared lamps on it, like a heat lamp in your bathroom. Quite literally the same technology. And heat up the whole board all at once. Again, let it cool. Don't touch it. It'll be pretty hot for a little while. To try to prevent myself from getting too screwed up, I'm not going to do all the 0.1s until last. Because I need C5 and C3 here are supposed to be 10 microfarads. So let's do those now. We'll do the oddball values first. And then and then all the huge number of 0.1s will go last, and we will be less likely to put one in the wrong spot. At least that's been my experience. in the situation here. You can see I actually got a solder blob there and another one on there, and actually some in here. When I was doing the FPGA, I also got one on the C14. So it turns out that I've already done one of the two pins like I did up here. As long as you don't get too much solder on all these extra pads around here, it's not too bad. If you get a lot on there, you might want to use hot air to put the part down like I did the crystal here, because you end up with both pins got solder blobs on there, and it'll cause it to lift up off the board. It'll be uneven. It'll be weird. So you generally don't want to accidentally get solder blobs all over the thing. We try to avoid that, you know, as a general rule. Guideline, really, you know. Don't make a huge mess on your board. Here we go. C3. All right, here we go. On there, put it on there. It'd be nice if it was like somewhat straight. This is looking crooked. Shit, I just soldered it onto the tweezers. Nice. Okay, so you get the one that's already melted, go in there. I'm going to hold it with the tweezers and do the same game. Like, make sure that the remaining pad is at least half uncovered. If I can hold it still, would be nice. Oh, jeez. It sticks up in the air and you haven't finished it yet. You can always kind of like pull back and put it back in the tweezers the way you need it, and then start again. Oh, there we go. Like I'm about to do right now. Come on. Get in there. It might be that oh, dang it. I might have gotten, wow, that's a mess. Come on. Might not have gotten enough solder on that pad. It's possible. So I'll get some more soldering on the old iron tip here. There we go. We'll try it again. Alrighty. I always turn it around and come at it the same way rather than try to hold the iron backwards. Now, it looked to me like I boiled away an awful lot of flux on these things, so I'm going to put a little extra dab on there. Because when these things dry up like that, you're going to have a big problem. Trying to get the solder to just stay on there. Oops, if it doesn't have any flux. Now this part looked like it heated up both ends and came loose. We'll probably do the same thing on the other end here. Might be careful. If that's the case, you can always just hold it like you did when you did the first pin. It's also, yeah, this is a mess. The thing just really conducts a lot of heat. Now, when you're done with these, it's also possible that I never really had it soldered in right in the first place. It's possible. Oh, man. It looks like this just conducts a lot of heat. And if I heat up one end, the other one's going to go. So whatever brand these capacitors are just going to do that. So if that's the case, like I said, you just hold on to it the whole time with the tweezers while you're putting it on there. I'm going to leave them the way it is. I don't know if this is entirely just a very thermally conductive part or not. I'm going to go back with the hot air when I'm done with the other parts and reflow all this stuff in here and there for sure, just in case I got a bad solder joint on one end or the other of this thing, okay? So what other oddballs do we have? It turns out one of these is a 4.7 microfarad capacitor. And that would be C25. So let's do that one. Again, we'll put a little bit of flux on there. A dot on one end first. Whoa, get in there. Okay. Okay, 25 is the 4.7 microfarads, and a little more solder on the tip. Okay. All right, that looks good. And I'm going to go around now and do all the 0.1s just to get them all out of the way. We might as well start with the hardest one. And we'll start with the hardest one first, with the tight quarters over here. Get the pre-soldered pad right there. Okay. Turn around, do the other one. With more soldering on the iron there. I want to hold on to it in case I heat it up enough to pull up the other end. Mm-mm. Shit. Boy, I cannot get the solder to go down on there. Now, it could be there's not enough flux. That's got to be it. I mean, otherwise, what the heck is going on there? Yeah, that seems to be the problem. There's some solder on it now. All right, now do this one. Mm-hmm. The cap's looking pretty good on there, if I say so myself. Okay, let's go ahead and do the resistors. Starting with these two here are 17 and 18 or 5.1K. These exist to tell a power supply if you plug this into a USB-C power supply with the correct cable, that power supply will be told to supply up to 3 amps to this design if we so desire to pull it, which should make this capable. If you put this jumper in here and you plug this in, you could actually power a whole Raspberry Pi off of this connector if you really wanted to. And vice versa, by the way. You can also put this jumper in and not use this connector, power up a Pi, and that will then power up this board. So that's why we have it set up that way. Nice little bit of flexibility. As you can also power both of them independently if you really wanted to. Although I don't really recommend that. It wasn't really designed for that, with that in mind. Because, you know, if you power this board and you power a Raspberry Pi, if one of them's on and the other one's not on, you can end up with overdriving some digital inputs or outputs and things like that. That's usually not a good thing to do. Unless you built a circuit with that in mind, which I did not do in this particular case. So one or the other, but not both at the same time, is what I got in mind. Same thing as before. And just like ceramic capacitors, resistors are not polarized. But if you really want, you know, a little touch of class, what you can do is make sure they're all oriented the same way, which would be kind of neat. Then you could read them all, but they're pretty small, and I can't read them without a magnifying glass anyway, so I'm not going to actually take the effort to do that here. Although there is a side of me that really wants to know that they'll present themselves in an orderly fashion. All right, one down. Here's the other one. Same rule as before. Put it in there. Make sure that you've got some pad there exposed. You will be cursing up a storm. At least that's the case for me. In the next few minutes. Solder on the tip. Oopsie, I just moved it. Either that, yeah, that's called a tombstone, by the way. If it flips up in the air like that, see how it's up on an angle? It stands up like a tombstone. That's what they mean by that. And if you don't get them in right, they'll stand up, and it's really annoying when that happens. Sometimes they really don't want to go back down. I think I got it. Looking okay there. Well, that happens if the part can conduct a lot of thermal energy through it and melt the other end while you're playing with this one, which is probably part of the problem I just had. It'll also increase the odds of that happening if you don't put a lot of solder in the first pad when you're getting it started up. Well, I think both of these connect to ground, so the pad I'm soldering on right now goes into the ground plane. It has thermal relief, but as you can see, the thermal reliefs are not that relieving at times. So it may have been a good idea, is what I'm thinking here, to put the pre-solder the pad with the larger thermal relief on it, and then use the iron to put the second pad with the less copper on it, so you have less clowning around. And I'm reminded of that almost every time I do a project, about halfway through the soldering process. Okay, so there's my 5.1 Ks. Well, there's a pair of 100 ohm resistors over here and over there as part of the low pass filter for the power that runs the phase lock loops on the FPGA. So looking closely, we've got this end goes out to a via here, which is going to provide some thermal sinking, which can make this harder to solder, probably that pad than this one, which has a little trace that runs over that capacitor. Same thing's probably true on this side. Yeah, this has got a little trace going this way, and then a little bit of meat coming up that way. So, but otherwise, these are not that big of a deal. If you put no thermal relief on these, then what happens is soldering becomes incredibly difficult. If you're going to work with a hand stick like I am doing here, because you have to heat up that entire copper area just to get the solder to adhere to it. You're going to put it in an oven or something like that, it makes no difference at all. Feel free to not provide thermal relief. But honestly, that is probably not a good idea either. I was working for a place once, and I designed a board that some of the older engineers told me, why am I putting thermal reliefs on everything? And I should just lay the end of a bypass cap or something right on the ground plane. So I did that. And boy, was it hard to rework that board if you wanted to play around with it, take a part off or something like that. So that was the last time I did that. I mean, okay, for machine assembly, maybe it's better. You can get tighter packing of your components and all that. And again, if it's machine assembled, I'm sure it's fine. But if you touch it with your hand, no way, man. I don't know. Throw something in the comments below if you have an opinion on that. I wonder what happens, thermally, if you put no relief on a pad and it's on a copper fill or something like that. I'm having a hard time getting the iron. There we go. Even if you're going to machine solder it in an oven, is there anything wonky about either doing that or not doing it, for that matter, that can cause something weird to happen, like uneven cooling or something like that? I don't know. Oh no, I unsoldered it. All right, well, that one might be a little wonky, so I'm going to go ahead and in there and reflow that again when I'm done here. But those are the 100 ohm resistors. The rest of the resistors on this board are 10K, and they are 16 and 15 down here. This resistor R5 right here, 3 and 4. And that's all the 10Ks. These over here are 330s. They're the current limiting resistors for the LEDs. Now I'm going to prepare the LEDs. I'm going to put a little dot on the row of pins. Just like all the other ones. And then go back and hit the other side. This is all it should take. If you're having trouble getting these little dots on there, it means you probably don't have enough solder on the tip. Looks like I can do 3 or maybe 4 of them before I got to reload. No. The solder's not where I want it to be on the tip of the iron. Not running down where I want it to go. There we go. There we are. Well, most any old LEDs will work on this. I've got the 603 jobbies that I got from Spark Fun. They were doing some sort of a factory unloading of these or something. Okay, so when you take these out of the package, you can flip it upside down and grab a little magnifying glass or something. If you look closely at these, there's a little pointed, like a T underneath there. And the point of this T points at the anode. The anode end goes inside this box over here. So the anode, the T on the bottom should point towards this over here, all right? So that means if it's already pointing there while I hold it this way, when I flip my tweezers over this way, it's still pointing towards the tweezers, right? And you can get it to hold, you know, in a reasonable angle. For soldering like this. It's hard to do on the camera with all the focus and depth of field, but sometimes I will at this point also grab my loop and double and triple check that it goes in the right way. Now D2 over here is the power LED. Probably a better idea to do that one first. And you always know when the power is on. This has been a problem for me in the past on occasion. I leave a power on a circuit while I'm poking around in there because I never put a power light on it. And that turned out to be a bad idea. But otherwise, these are just like soldering in the caps or the resistors or whatnot. You just need to make sure that the they're in the right way around. If they're backwards, you got yourself a problem. Okay. And as usual, a lot of this stuff looks much better once you clean off all the flux. And if you've managed to solder in a bunch of parts that are totally crooked, you can always reflow with some hot air. And line them back up nice. If that is your goal. Let's start with the ones away from me first. The LEDs kind of have this little metal plate sticking out the ends of them, which I think are easier to solder onto than the little thingy, the little metallized ends on, say, a resistor or a capacitor or something like that. Whoops. Oh, no. If that happens, sometimes you can carefully get in there and re-grab it. Not a problem, okay? All sorts of crazy stuff happens when soldering. Now, it helps a lot if you get it right the first try, but no one does every time. So you have to really become good at rolling with it. Well, what it really comes down to is it helps if you get it right on the first try. And if you're neat and careful, that can happen more than not. But you will screw up, and you're going to have to fix it when that happens. Well, even if I ordered this board pre-assembled, I mean, that's only useful if the design works. And quite often, if it's pre-assembled, it's hard to test certain things. You certainly can't test like the power supply in isolation. I suppose you could if you designed your power supply with jumpers and things on the board, certainly in your first draft, or you route some tracks so you can go in there with an X-Acto knife and cut them and disconnect it from the rest of your circuit. But my point is, you're probably going to have to, on occasion, rework a board and take parts off when you've made mistakes in your design. And you'll have to put them back on, or maybe different ones back on. Maybe you designed a 100 ohm resistor where you needed a K. You need to reach into your board and you need to be able to replace the parts. And if you never have any practice, is my point, you'll ruin it. And you pay extra money for the setup and all that stuff. Granted, this takes a long time. I'd really like to not have to spend as much time doing this as it takes. You'd probably never want to pay for this in terms of time professionally. But as a hobby, this is quite rewarding for me, I think. Do all this, put all these parts down, turn it on, and then it work. Holy crap. That is definitely cool. Oh yeah, I got to tell you, this is probably some of the straightest aligned rows of parts I've ever done by hand like that. So don't be too frustrated if yours doesn't look that way, because don't be too frustrated if yours doesn't look that way, because I've got some practice. I wouldn't say I've got a lot, honestly. I don't make a whole lot of boards. I've probably made a total of 20 boards like with this kind of soldering involved in it. So in terms of like experience, that's roughly where I'm at, I think. Without any exaggerations. That's probably about, I doubt I've even made 20, but, you know, probably including things that I've, you know, experimented with and tossed in the garbage. Now, when you do this, you should see them move a little bit. If they're misaligned, you'll see the solder kind of glisten and kind of change its change its texture a little bit. I think it's actually already reflowed. It doesn't take long to do this. And I don't want to burn up the parts, so I think that's good there. I wanted to do this. Oh, that's hot, man. These resistors that I just put in, because they really don't look too straight. See how that thing just lined itself up there? That's what you want to see. Again, you be careful when you touch these boards, because the board itself gets very hot. I mean, it's hot enough to melt metal, so you don't really want to grab it right away. So R6 just tombstoned. Oh, did it? No, it didn't. That's what it's supposed to look like. This focus on this Pi camera is giving me trouble. There we go. All right, so here's D2 and R6. D2 should turn around a little bit, I would think. Maybe that's as far as it wants to go. That's fine. If you can mess with it if you really want to. I don't recommend it. This is the trouble ugly mess over here. That resistor right there, I didn't like the way it looked. Let's see what happens if we reflow that guy. He should sit down right nice next to those two capacitors. R1. Yep, there you go. See, that's what you got going on there. This also happens inside a pick and place, or not the pick and place machine, but in the reflow oven. As long as the pick and place machine gets these parts anywhere near where they're supposed to be, they'll align themselves on the pads. It's really a neat process. It really is. Okay, there you go. Now I got to do these last guys over here. There you go. Perfecto. All right, not bad. D2 is a little crooked. I don't know why that one didn't want to straighten up. Now, these look like I burned them, but what that is, it's probably the flux. I hope it's the flux. If we just take a little screwdriver and wipe some of it off, you should be able to see that that's what, yeah. Once the board's still very hot. Let it cool down, then we'll clean up the flux with some alcohol. And then we can move on to the next pieces. Let's do these test points. This one here and the one over here. Next here, all right? Now, these are kind of annoying to solder on, but I really like them because you can get, they're to hold the ground gator clips for your scope and stuff. When I don't have them on my boards, you know, what are you going to do? You're going to try and clip it onto a pin on here or something. And then the gator clip kind of wanders around, and then it risks shorting out against something on the board. So I'm pretty happy with these. Certainly as an idea. And here's one of them. they're kind of hard to actually get soldered on there. They do have a top and a bottom, okay? The bottom is this part here that has this joint. The top is that metal thing there, and it's got these like teeth sticking out the side, so your gator clip can grab onto them. So it's going to go on, oops. So I'm going to put it on this way, all right? Now, I'm going to do this by first putting a solder blob on the ground pad here. And then I'm going to solder the part onto it. These are kind of hard for me anyway to hold on to with the tweezers and everything. They like to keep flipping upside down. And these are really annoying. Honestly, one of the most annoying things. I tried to learn how to solder. Now I'm going to try and hold it like this. Once I get it in there, it'll probably flip up and do something weird. I'm going to put the iron in that, oops, get this up here. Now I'm going to put the iron kind of in this thing here while I'm trying to solder it in order to heat everything up, okay? There you go. That's what I remember. So even if I get it on there upside down, I'll consider it a success. Come on, this is just annoying. Come on. There we go. That's, sticking up all over the place. Looks terrible. Sometimes when I do these, I can actually use a gator clip to hold on to the thing like this, and then makes it easier. Solder maybe, I don't know. What I'll probably do is solder the clip into the test point is what I'll do. Now these are all, you can also reflow these if you really want to. And that might help if it's crooked or something on there. All right, so there you go. That's on there and it's a little bit crooked. Okay. But I'm going to reflow it when we're done. So just get it in the right spot. Get enough solder on there to do the job. Oops, a little bit of extra flux. In this case, I probably don't need flux because there's flux in the solder. And in a giant pad like this, with plenty of solder, it's probably enough to do the job, but I usually put a little extra on there anyway. All right, so I'm going to try and do this again with the clip, with the gator clip on there. I'm going to try and hold it. There you go. I'm going to grab it like that, all right? And then I'm going to try and set it down on there. This is only like the 4th time I've ever put one of these on, so I'm still trying to figure out my technique. The gator clip seems to be working pretty good. That's what I settled on last time. It helps if you pre-melt the solder and then kind of come at it like that. At least it does for me. All right, maybe get a little heat on there. Okay. Now, that wants to wobble a little bit, and it's not really on there, right? You can see it's a little up in the air. So what I'm going to do is reflow that sucker. Now I'm going to blow the heat away from the FPGA and the other parts on the board. As long as it's relatively flat, it should not tombstone. If it does, you're going to have to grab it with a gator clip or something, or the plier, tweezers or something, and realign it. So I'm going to grab the tweezers and get ready for that inevitability. Ooh, look at that. Woohoo! That's on there. That was perfect. That's exactly what we want to see. Might as well do the other one while we're here. So the goal here is to get it in the right place. Get enough solder on there for it to do its job. And throw some heat on there, reflow it, and it will then look perfect. You know, like I did it right on the first try. All right, I cleaned it up. I think this looks pretty darn decent over here now. And after we add these diodes here, D1, 11, and 12, we have all of the components in here ready to go. So all I need to do now is throw some headers on here so I can plug it into a Pi and program it.